For 25 years, the futuristic world we were promised remained trapped behind glass. But the era of screens is ending, and real automation is finally stepping onto the physical factory floor. We spent the first quarter of the century refining software, apps, and social media. 2026 marks the point where we move that intelligence into a physical body capable of navigating the real world. This transition to walking machines represents an immediate disruption to the global labor market. Because these robots fit our existing infrastructure, climbing our stairs and using our tools, they can start working without us needing to redesign a single warehouse. Behind the viral videos of parkour robots lies a fierce, hidden legal battle between the US and China. This chart shows the global competitive landscape in 2025. Chinese companies currently control nearly 90% of all humanoid robots sold, leaving the rest of the world to compete for a 10% share. This race is being fought across three distinct battlegrounds: the brain, the software control systems; the body, the physical durability and kinematics; and scale, the capacity for extreme mass manufacturing. The winner of this patent war will do more than just build a better machine. They will control the infrastructure of the future economy. Tesla's approach is centered on engineering a unified central intelligence. The mechanical frame is secondary to the software that orchestrates it. Patent WO2024-0729-84A1 reveals how they coordinate 56 degrees of freedom, independent joint movements like a wrist rotation or knee bend. Tesla manages this complexity using 6 optimized actuator types across the body, all directed by one central brain. For navigation, Optimus uses vision-only occupancy networks. These are AI systems that process standard camera feeds to build a three-dimensional map of the surroundings. By removing traditional LiDAR sensors, Tesla sheds the significant weight required by laser mapping hardware. This software-first model allows a single robot to master a task, like sorting battery cells, and instantly distribute that training to every other unit in the fleet. While Tesla prioritizes the brain, Boston Dynamics focuses on physical durability, building robots that can instantly recover from heavy impacts. The new Electric Atlas is designed for 24/7 operation. It carries an IP67 rating, meaning it is dust-tight and can survive immersion in water, and it can autonomously navigate to a charging station to swap its own battery without human assistance. This hardware follows a human-scale philosophy. By building robots that match the human form, companies save billions. These machines use the same equipment, workstations, and stairs human staff already use. These engineering improvements have moved the Atlas out of the lab and into active production. It is now a rugged, independent industrial tool, capable of sustaining high-output labor in conditions that would break standard electronics. China's strategy centers on overwhelming Western engineering with mass production, modular design, and absolute speed on the factory floor. The 2025 sales data shows the massive gap between prototype and deployment. While American companies were shipping around 150 units, Chinese manufacturer Unitree sold 5,500 humanoid robots. Following their electric vehicle strategy, Chinese firms use modular parts to drive down costs at an extraordinary rate. This 2026 market tiers chart illustrates the result. The Unitree G1 is $16,000, the cost of a budget car for a bipedal worker. In the race to automate, sheer manufacturing volume and rapid deployment are the primary metrics that matter. The winner is determined by who can put the most boots on the ground the fastest. The next major frontier isn't the factory floor, it's the living room. The home environment represents the ultimate multi-trillion-dollar market for robotics. Moving into the home requires a shift from cold metal to soft, clothed bodies, as seen in the 1X Neo. This physical padding is essential for safety, ensuring that collisions in tight domestic spaces don't lead to injuries or property damage. These robots use embodied AI to learn chores through trial and error. Embodied AI refers to software that learns by physically interacting with its environment. By washing dishes or folding laundry in early adopter homes, these machines refine their motor skills in unpredictable settings. But this transition requires a major psychological shift. For these machines to become household appliances, we have to start viewing them as interactive companions rather than industrial tools. A recent projection by Bank of America forecasts the scale of this shift. They estimate the global humanoid robot population will cross the 3 billion mark by 2060. This transformation is happening without a singular, dramatic event. Instead, these machines are quietly integrating into our daily routines, in both factories and homes. We are witnessing the integration of artificial intelligence into our physical world. What was once a conceptual promise is now a physical reality.